In number 6, we got a 2 by 2, and it's regular, right? It's regular because if you look at even the first power, all the numbers are positive, all the entries are positive, no zeros. So it does reach a steady state, and we want to find that. So I'm going to let x be the steady state. Now there's only 2 states, so I'm going to call this a x and y, and we're going to try to find these values of x and y. Now, a steady state is such that if we apply a transition to that steady state, we'll be right back at the steady state. So let's do this. We're going to have, here's t, I'll read down the columns, 0.2, 0.8, 0.3, 0.7. Multiply that by our steady state vector, xy. And if we make a transition to xy, we're right back to xy. That's what it means to be in a steady state or a stable state. Now, let's multiply these matrices here on the left. So, you know, over and down. So 0.2x plus 0.3y. So let's do it up here. We will get 0.2x plus 0.3y. That's equal to x. And then over and down in the second one, 0.8x plus 0.7y. That's equal to y. So there's our system. But now to solve this, you know we need all the variables on one side, all the zeros on the right, or constant anyway on this side. So let's subtract x, and we'll subtract y. So if you subtract x, 0.2 minus 1, right? 0.2 minus 1 is negative 0.8x plus 0.3y. That's 0. And if you subtract y, 0.7 minus 1, just like 7 minus 10, right? You get negative 3, but now we get negative 0.3, so we get 0.8x minus 0.3y equals 0. But now you can see this, right? This second equation is really just the first equation, but opposite. So this is really not an independent equation. So we've seen this before in our examples. What we can do is just eliminate one equation and replace it with an independent equation, which is this, and that comes from over here, right? I'm back over here on the left. You know that x plus y, that's equal to 1, right? If you add down this column, you get a 1. So why don't we RREF, now I'll read down the columns, negative 0.8 and 1, 0.3 and 1, and 0 and 1. I'm going to RREF this, and I got, well, you know how it starts, 1, 0, 0, 1, and I'll put the line in. And then I got 0.27 and 0.72. All right, so our steady state vector is 0.27 and 0.72. Right, that is our steady state.